Welcome back. Well, in previous video, we talked about the scaling of pods, and we did the lab with manual scaling of the pods. I still have the same setup. It's been like 2 or 3 days, but I managed to keep the setup. I have the Kubernetes cluster. Not the same cluster. I did created it again. So I have single instance running for this Kubernetes cluster, and I have the same voting app that we are using from the beginning. Now, in today's video, we are going to talk about auto scaling, because scaling manually is useful when you're working on your cluster in your lab or trying to develop something. But if we talk about production, where the application is involved, the users are involved, it is always be auto scale, right? So there are ways that we can do the auto scaling, and as I said, manual way we already talked about, and for auto scaling we have HPA. That is horizontal pod autoscaler. So in this lab, what we're gonna do, let me try to explain a little bit. What we're gonna do first, we'll try to understand the concept as well. We'll run the deployment, check the pods, then we'll do okay, scale it with HPA. Then we'll check the scaling with Hey-tool. Okay, and just wanted to inform you, for HPA, we should have the limits configured for the pods. What do I mean by limits? It is the CPU utilization, or how much it can go, like it can use, right? Like 250 milli CPU, like that, which is must. So let me take you to yes, okay. I'm just trying to find the file. Yes, there it is. So if I show you cat Azure vote all in one YAML, what I mean by the configuration is this part. The resource utilization is the right word. Okay. So why this is prerequisite? Because HPA, or horizontal pod autoscaler, is based on the metrics, right? So we should have this limit once the condition is like if the 50% of utilization, if it hits the 50% of utilization, we need one more pod or two more pods. So for that, we need this information, and HPA is based on metrics. If I talk about metrics server, this is auto provisioned for Kubernetes cluster, which has version 1.10 and above that. Else you need to install it manually. I'll share the link in the description if you have the lower version than that. And this metric server is used to provide the resource utilization. So that will help HPA to do the auto scaling. Right. So without wasting any more time, let's focus on the lab and try to understand each and every concept of HPA, right? So what we're gonna do first, well, we are going to kubectl. Okay, right here, kubectl, apply. I'm gonna run the same application. And it will give us two pods, two deployments, two parts, one for the back, one for the front. We have already seen it a couple of times. So we're already aware of this application, and that's the reason it will help us to understand better all other aspect of Kubernetes. So if I do kubectl get pods, I would have both the pods running, the back and the front. If I do kubectl get service, I have this service load balancer with the public IP addresses. And if I copy it and try to browse, I should have the voting app up and running. It's loading because I should given it a little time, but I think it's good to go. We have this app running. It's coming from these pods and this Kubernetes cluster. All right, now it's time to do what? It's time to auto scale the deployment. Now, as always, there is imperative way, there is a declarative way. Declarative way is always like creating the manifest file, which is always better where you have a centralized management of the configuration, the best practices. Okay, you would learn these practices in the DevOps and other methodologies. So let's check the imperative way first. That would be like very simple, kubectl auto scale. Okay, we are auto scaling whom? We are auto scaling deployment. Which deployment? We are auto scaling Azure Vote front. Okay, this deployment we are auto scaling. And how are we auto scaling? We are putting the condition as CPU percent is equal to 50, right? If the CPU percent hits the 50, we need minimum pod as 3 and maximum pod as 10. Okay. You should give this minimum and maximum. If you would not give the maximum, you know what it means. We do not have that much resource available for sure, so that it would keep creating in an unlimited loop or things like that. So we define it until, or maybe there is some default value, but we are trying to learn the auto scaling. Let's stick to the topic. So if I hit enter, it created the auto scaled, right? And if I do kubectl get pods, how many pods do you think we have? We were having 2 earlier. If your answer is 4, then you are correct, because we made 3 as minimum for the front, right? So in total, we got 3 for the front, 1 for the back, we got 4. So it scaled automatically. Now, if we increase the CPU percent by sending a lot of requests, then it will start increasing the pods. So that's the imperative way. And let me quickly check, show you the declarative way as well, so that we'll also try to put the pressure. I don't think pressure is the right word. Put the load on this application, and it will auto scale the pods. So kubectl get HPA. Just wanted to check. There is this HPA created because we ran the imperative command. So let's get rid of this kubectl delete HPA. What did I do wrong? Oh, I should have provided the name Azure vote front. Okay, now it's deleted. What do you think? How many pods do we have now? Well, if your answer is 4, I think you are correct because it's already there. Now, if I do kubectl apply -f and our manifest file, this will make it, I consciously giving pauses so that when you're watching this video, you can give your answers, okay? So now as it says configured, so we would have number of ports back to 2, right? That's the only reason towards terminating. That's the only reason we should always make changes at one place. That's the manifest file rather running the imperative command, but we should know as well. So that's why this now let me show you. I do have this horizontal pod autoscaler as kind in my HPA YAML file. If you see, this is the resource I was talking about. This is what the HPA, horizontal pod autoscaler, and this will take care of autoscaling, and that's how the manifest file is written. And if you see, it has the same configuration. Minimum replica is 1, maximum is 10, and target CPU utilization % is 50. All right. Same goes with the back. It's fine. Just wanted to show you. Now what we do the same thing, kubectl apply -f and the name of the file, and it's deploy for both the deployment, right? Minimum is 1, maximum is 10. Very good. Now if I do kubectl get HPA, you would see I have minimum pod 1, maximum pod 10, replicas 0. And you see the target, this is unknown because it will take few minutes to get the information from the metrics server. What is the usage and things like that. Once it has the information, it will act accordingly by applying the rule. 50% increases, it will increase the pod. What do you think if we hit the maximum pod as 10, what would happen then? Keep thinking, we'll answer later, but just wanted to show you, if I do kubectl get pods, we have 2 pods running, right? Let me open another window, and I have this tool with me. This is known as I said at the beginning, Hey tool. Yeah, you think that's funny name? I agree, it's a funny name, but this is all right. So this is the tool that I was talking about, the Hey tool. Let me paste it here. And you see, I need to give the public IP address of my voting app, and it will send 20 million requests on it. And as soon as it gets the request, it will increase the number of pods to manage the load. That's the plan, right? So if I do this and I hit enter, it will take few minutes for sure. And let me go back here and let me put this on watch. kubectl get pods -w. If I have put it correctly, yeah, everything is fine. Now I'm just watching right now. Terminal container button, what is this? Okay, now it is 2, but this is on watch, and we have put this Hey tool to send the request on our public IP address for this voting app, right? Now, as soon as the load increases, it will start increasing the pods. We'll check that. We'll also try to describe the HPA and see how it acts. So let's wait for a few minutes. As you can see, as you can see, it started creating more pods pending. It's getting information from the autoscaler, like we need to increase the pods, right? If I break this and try to check kubectl get HPA, we'll start getting, you see, target is 148%. That means CPU. And we only said if it is 50% or more than that, then increase the parts. Now you can see it has gone up to 3 replicas. But if you'll let it running, it will go, let's see how long. As we said at the beginning, if maximum is 10, will it be 10 or will it go more? For right now, it created 2 more pods, and now it's balancing the load, and it will again increase the number of pod as soon as it hits more than 50%. So that's how the auto scaling works. And if I stop it, because else we need to wait a little longer, but we needed to understand the concept. So that's good enough to understand the concept, how it goes. Now what I'll do kubectl get, not get, let's describe HPA. Cool. Now let me make it little bigger. Now you can see right now, it has the information like 1 or 10. It's increasing, and to give you the answer, it will not go over and above 10. It will maintain the configuration. It will respect the configuration, else other deployment will get hampered if only one deployment started getting all the resources. So it will maintain the configuration, like maximum is 10, it will stop on the 10, right? And here we can see able to scale, successful rescale reason, CPU resource utilization. So it also gives you the reason, right? And that's all with respect to auto scaling. And in this video, we learned the auto scaling of the pods, but once all the pods are scaled to the maximum, then of course we need the auto scaling enabled on the Kubernetes cluster as well. What I mean by that, we need more nodes. So we'll see that in the next video. Till then, take care. Goodbye.